All right, so today's lesson is 4.04, Understanding Dilations. You'll need your math notebook, pencil, and probably your calculator, so please make sure you have those things before you proceed, and we'll go ahead and get started with our lesson for today. So our target slide here says, today I am exploring dilations and ratios so that I can better understand the properties of dilations. I'll know I got it if I can analyze two figures to determine the scale factor. So what is a dilation? So you should be taking notes or screenshot and save this electronically. Please make sure you save your notes. So a dilation transforms the size, but not the shape or figure. So it can go bigger or smaller. The pre-image is the original or the old figure. Important to know which figure is the pre-image or the original one and which one is the new or dilated one. So the new dilated image is represented with a prime, just like we're doing that with slides and reflections. So you'll see that little prime symbol next to the point if that's the new one. So scale factor is the ratio of the new side length to the old side length. And that gives you the dilation. So that's the scale factor, new to old. Greater than 1 will enlarge the figure, less than 1 will reduce it. So here's a scale factor of 2. This is our original one. Scale factor of 2 makes it larger. The image is the same shape, just different size now. So this circle goes, when it's a scale factor of 1/2, that's less than 1, 1/2 is, so it becomes smaller. So what are the missing scale factors here? So this A is the original one. It goes from 4, you can use any corresponding sides, 4 to 8. So the new, remember the scale factor was new over old. So I'm going to put that in here. So we're looking for the new length over the old length. The new length is 8. The old one is 4. So the scale factor is 2. So on our second example, A is our original, because you see the arrow going this way, goes from A to B, so it becomes smaller, so the scale factor has to be less than 1. So here's our original. And this is the new. So we want new over old, just like with the top one, so 3 over 9. I just used this one and this one. So the scale factor is 1/3, so it's reduced in size. A couple more examples when you're looking at just objects here. So our map of the United States, this is the pre-image, and it becomes bigger when the scale factor is more than 1. Here's our original, the new one. It becomes smaller when the scale factor is less than 1. Let's find the missing scale factor here. Okay, not so friendly numbers, but you have a calculator. So we're going to go ahead and use, this is our original, because we've got the arrow, follow the arrow, and the new. So we want to put the new over the old or the original. So the new is 4.25 and the old is 2.125. So you could go ahead and just do the division, and you can write that scale factor as the decimal number that when you divide. So that's another way you can do that, 2.125, and it's actually 2. Isn't that nice? It came out to 2. So our scale factor is 2. It's larger than 1, so it gets bigger. So let's practice a few problems. So we have triangle ABC. This one is the new one because it has the prime. Is a dilation of the original one. What is the scale factor? Okay, so remember, scale factor, we're going to do new over old. Now, I am going to play it smart here, and I'm going to use 18 and 9. Now, my new number is the 9. The old one is 18. So the scale factor is 1/2. Or you may see it, like if it was a multiple choice, you could see it as 0.5 if they changed it to a decimal. Same thing. All right, let's look at this one. So we have triangle ABCD is our original one, and the new one is smaller, so that tells us the scale factor will be less than 1. So now here you got to be careful. This starts at 3 and it goes to 12, so that length is 9. So we're going to put 9 here. And on the other one, it corresponds with a B. It goes from 1 over to 4, so that's 3. And that's our new one. So new over old for our scale factor. The new is 3, the old is 9, so the scale factor is 1/3. And the new object is definitely smaller, so the dilation is smaller. All right, last one. So a polygon is graphed on a coordinate grid with x, y representing the location of a certain point on the polygon. The polygon is transformed using this rule. Because this just means that this is our scale factor. It multiplies the x value, multiplies the y value. So let me go ahead. I'm going to go back. Let's look at this is on a coordinate plane. So if you look at the x value here is 4, and this is 12. And the scale factor is 1/3. So 12 divided by 3 is 4. Or you could say 12 times 1/3 is the 4. So that's all that is saying on the next slide, is that this would be 1/3 x, 1/3 y. So that is the algebraic rule, which we'll actually get into more detail with that with our next lesson. But we'll go ahead and look at this one because it's really not too complicated here. So this value is the scale factor. So this is what we're just trying to answer here. If A is greater than 1, the image of the polygon is congruent. It's either going to get bigger or smaller. It's not ever going to be congruent when it's dilated. B, if it's between 0 and 1, the image of the polygon is congruent. Again, no, not going to be congruent. It's got to be smaller or larger. If A is greater than 1, the polygon is smaller. Okay, remember if it's greater than 1, it enlarges it so it becomes bigger. So that is incorrect. I hope it's C. It says if A is between 0 and 1, the image of the polygon is smaller. That is correct. Please make sure you complete the OMS lesson. Reach out to me if you have any questions.